Today I'd like to take a look at Chi Square Inference tests. So please open up your study guides to this particular section. Now in the past we talked about inference tests using numerical data. Chi Square tests are used to test the counts of categorical data. We use the term Chi Square, the Greek letter chi, to represent a Chi Square test. Now there's three types of Chi Square tests. Our first test is a goodness of fit test. Now in a goodness of fit test, we use univariate categorical data from one sample. We want to see how well a fitted model reflects the actual data. So a goodness of fit test will tell us whether the actual model is really reflected by the actual data that we use in our particular sample. Now a chi-square test for independence uses categorical bivariate data from one sample. Recall that bivariate data is two variables, and we typically want to measure the relationship between those two variables. In the chi-square test for independence, we want to see if two categorical variables are associated. Are they associated or are they not associated? If they're associated, we say the two variables are dependent. If they're not associated, we say the variables are independent. And finally, we have the chi-square test for homogeneity. Now the test for homogeneity uses univariate categorical data from two or more independent samples. In a chi-square test for homogeneity, we want to see if two or more populations are the same. Are they homogeneous? Now we can do this with two populations, or we could do it with several populations. Once again, all three of these chi-square tests use categorical data. The goodness of fit test, once again, is a single variable univariate study using categorical data from one sample. The test for independence, we use categorical bivariate data from one sample. And our test for homogeneity, once again, we use a single variable, but we're using categorical data here from two or more independent samples. Now the chi-square distribution is a right-skewed distribution. Different degrees of freedom basically have different curves. And as the degrees of freedom increase, our chi-square curve shifts towards the right and becomes more like a normal curve. So once again, just like the t-distribution, as our degrees of freedom increased, our distribution becomes more like the standard normal curve. Once again, chi-square distributions are typically right-skewed distributions. Now let's talk about the conditions for inference on a chi-square test. There are two conditions required for chi-square inference. Once again, we always start out with an SRS. We first begin by selecting a reasonable simple random sample of data. Once we've sampled appropriately, we need to make sure that we have counts of categorical data, and we expect each category to happen at least once. Then our sample size needs to be large enough, and to ensure that our sample size is large enough, we would expect to have at least 5 in each category. Now we can combine these together and call our last condition expected counts. So once again, we have an SRS of data, and all expected counts are at least 5. Be sure to list the actual and expected counts in your conditions for inference. Now the Chi Square Test Statistic value is equal to the summation of the observed counts minus the expected counts squared divided by the expected counts. So we're going to take a look at the difference between the observed and the expected counts, and we're going to square that result and divide by the expected counts. We're going to sum up all the cells to get our Chi Square Test Statistic value. Once again, OBS represents observed counts and EXP represents expected counts in our formula above. Now let's begin talking about the Chi Square Goodness of Fit test. Once again, the Chi Square Goodness of Fit test uses univariate data. We want to